Hi, I'm Miss Hall, and this is lesson 1.10, consecutive integers. Let's first review what consecutive integers are. So here are sets of consecutive integers: 1, 2, 3, 4, 7, 8, 9, 39, 40, 41, 42, 43. Okay, so consecutive integers mean they come right after each other. They're the next integer. I know these only show positive examples, positive values, but integers can be negative as well. So let me just include a set of negative integers like negative 11, negative 10, negative 9. Fine. And so you can see this is a set of 4, 3, 3, and then I think that's 5. You can also get more specific and have a set of consecutive even integers. So those are every even number, right? So you start at some even number like 28, and then you go up to the next even number. So we've got examples of sets of even numbers, and again, we can do a negative example to show you that these can be negative as well. And then just like sets of even integers, consecutive even, we can have sets of consecutive odd integers. So we begin with an odd number, and then we go to the next consecutive odd number, so we skip every number. And these can be, let's just do a set of odd, that's only 2. Right. So to solve these problems that we're coming up with, we need to know the algebraic representation of how to represent consecutive integers. I think it's going to be helpful if I kind of have an example nearby. So let's say the first one is, say, 10, 11, 12, 13. This is an example of consecutive integers. And if the first value is x, the one after it, the second consecutive number, is going to be x plus 1. The third is going to be x plus, so we can look at in relation to the original, this will be x plus 2, or x plus 1 plus 1. And then the next consecutive integer will be x plus 3. So we got all based off the first integer. Now if we think about even, consecutive evens, and so let me just get some evens going here. The first, we're going to keep it with x, but then the next number will not be x plus 1, it'll be x plus 2, because you skip a number when you go up by evens. And then we have x plus 4, and then x plus 6. And let's check out some odds. And again, I'm just going to write myself an example here of consecutive odd integers. So I have something to reference, so x, and then the next one goes up by 2, so it's x plus 2, and then it's x plus 4, and x plus 6. So you can see that consecutive even and consecutive odd, the algebraic representation is the same because you just keep skipping every other number. Now where do we go from here? We're going to solve problems like this. Your friend is trying to find 3 consecutive integers whose sum is 39. Let's see if we can help them. What a friend we have. 3 consecutive integers. Okay, so 3 is going to be x, x plus 1, and x plus 2. It's going to represent those 3 integers. We know the sum is 39. So we know that x plus 1 plus x plus 2 is 39. I put those parentheses there just in case there was any kind of grouping thing I needed to take care of. There isn't any distribution or anything, so I can remove those grouping symbols. And now I'm going to solve. So let's see if I can simplify each side. 39 is all simplified, but we've got like terms here, so let's combine them and get 3x plus 3 equals 39. Then we can subtract 3 from both sides and get 3x equals 36. And then we can divide both sides by 3 and get that x equals 12. So 12 is one of the consecutive numbers, but let's go and say, so the numbers are going to be 12, and then x plus 1, 13, and then x plus 2, 14. And we can double check that these numbers are consecutive. Yes, they are. And that they add to 39. So 7, that's 9. Yep, they add to 39. Let's do another example. The sum of the least and greatest of three consecutive integers is 60. What are the values of the three integers? Ooh, the least and the greatest. Consecutive integers. So I'm just going to note those integers again over here. They are unknowns. So those represent the three unknowns. And the sum of the least and the greatest. So the sum of x plus 2 is 60. Let's solve for x. I will remove the grouping symbols. There's no distribution to do. Then I will combine like terms. Then I'll move the constant terms to one side, so I'll subtract 2 from both sides and get 58. And then divided by 2, 58 divided by 2 is 29. So let's write, so the numbers are going to be 29, 30, and 31. And so the sum of the least and the greatest, 31 plus 29, is 60, and that is correct. One more example. The lengths of the sides of a triangle are consecutive odd numbers. So we've got a triangle. The sides are consecutive odd numbers. What is the length of the longest side? So this is going to be important. If the perimeter is 45. So the perimeter is the distance around. So we have x plus 2 plus x plus 4 equals 45. Let's solve for x. Maybe you'll see that maybe we can do this with less steps than me, but I'm going to write them all out. Now let's combine like terms on the left side. Subtract 6 from both sides and divide by 3. So if x is 13, then we have 15, then we have 17. So the longest side is 17 is our answer. And we could add these up. So it's 30 plus 15 is 45. The perimeter is 45, and those are consecutive odd numbers. Now with the try, the sum of three consecutive even integers is 54. So we're going to add these all up, and we get 3x plus 6 equals 54. This will be 48. 48 divided by 3. If I don't have a calculator, I would do it this way to get 16. So let's write down what these three integers are. We've got 16, 18, and 20. And the sum is 54. Let's see, the sum of that is 34. Yep. So these are the three consecutive even integers